the video for Unit 3, Day 10, and we are going to go over how to write, how to use your calculator to find the equation for a tangent line. So this can actually all be done on your calculator. Just a sidebar here. We very rarely ask you to write the equation of a tangent line while you have access to your calculator, like during a calculator part. Usually it's a no calculator question, but every once in a while they'll give you the question, write the equation of the tangent line on a calculator part. So that's kind of advantageous if you know how to do it automatically, so that you don't have to do any calculus. In addition, this is obviously a really effective way to check solutions, like in the class activity, the circuit on writing equations of tangent lines. You can make sure that you've calculated it correctly before you move on to the next question in the circuit. So first thing we have to do is graph it. So I'm going to do this first example up here. Find the equation of the tangent line to the function indicated at the indicated point. This function is x squared minus 3, that quantity all to the fourth power at x equals 2. So I'm going to go ahead and put in that function. So I've got some brackets here, x squared minus 3 all to the fourth power. All right, so just get a quick look at this graph. Okay, so I've got an error in what I typed. Let's see here. Oh, I forgot the variable. That's problematic. There we go. Now I got x squared minus 3 out of the quantity of 4. Okay, so it looks like this. And a couple of things. First of all, we're only seeing half the graph, right? So if we zoom standard 6, there we go. Now we see the whole graph. So even power polynomial has that symmetry about the y-axis. So we want the tangent line at x equals 2. So x equals 2 is right here. So we're talking about this location we want a tangent line for. So let me change the window a little bit. Maybe, let's see, maybe we want to go from 0 to 4 and -1 to +2. So let's do that, 0 to 4 and -1 to 2. So we're really zooming in on that point of tangency. There we go. Okay, so it's that location right about here that we're looking at. In fact, it's up a little. It's up here at 1, right? If we put 2 here, we get 4 minus 3, which is 1 to the fourth power is 1. So it's actually right up here. Okay, so we want that point of tangency. We want that tangent line. So, you know, typically, if you look at the solution here, doing it by hand, we would have to find the y-coordinate, which I just did over here on the graph screen. So the y-coordinate is 1. So we know we're finding the tangent line at 2, 1. And then, of course, by hand, we'd have to differentiate this. So looking at the differentiation here in purple, I did the chain rule, right? Brought the power 4 down. And then the stuff inside the brackets stays x squared minus 3, new power cubed, and then times the chain rule here. 2x is the derivative of the inside. And so this is the expression for the derivative. And when I plug in the point, the x coordinate of 2, then I get a slope or a derivative of 16. So using that slope point form that you can find in the anchor chart in the front of the room, I wrote the equation for the tangent line in slope point form, 16 times quantity x minus 2 plus 1. So, so that is the slope of the tangent line. That's how you would do it by hand. But we can use something that's called the draw feature on your graphing calculator to give us the equation for the tangent line automatically with no calculus involved, which is kind of cool. So the draw feature is right here. I'm circling it with my cursor. It's a blue command. So that means I need to use the second key here. So second draw. and I want to draw a tangent line, so that's option 5. And I want to draw this tangent line at 2, 1. So it happens to be right at that point. But if it weren't, I could just type in 2 and hit enter. And there is my tangent line. So let me just do that again. Let me actually move off the tangent line. And let me clear all of that out. And let me go through that one more time. So here's my function. And let me go off that point just so that I have different numbers down here. So let me just kind of recreate that. So second, draw, tangent line, option 5. And I want it to be at 2 and enter. And so there's that tangent line. And here's the equation down here. So this is the tangent at x equals 2. And the tangent line equation is 16x minus 31. So all of these extra digits, of course, we've always talked about that calculator, how it rounds when it determines its values. So this is really, you have to read this whole thing as 16x minus 31. So think about writing this in slope-intercept form. If we distribute the 16, it's 16x minus 32 plus 1. That gets us the 16x minus 31. Okay, so that's how you can get the equation for the tangent line without having to actually do any calculus to find that slope using the derivative. So that's a really handy feature. And so you can use that to check your work. And obviously you can use that to answer any questions that you're allowed to use a calculator on. One last note, and that is the tangent line. I did this earlier, but I didn't comment on it. The tangent line is, since we access it through a draw feature, it's actually just something that's drawn over the top of a graph. And so if we have to get rid of this, it doesn't disappear on its own. We have to go back into the draw program and do a clear draw. And that will clear that line so that you can graph a different function on it and not have that line remain. So when I hit 1 here, that tangent line goes away. And that's how to get rid of it so that you can move on to the next problem.